recording. Yeah. All right.
Let me go ahead and search. All right. Well, hi everyone. Welcome to Wednesday, hump day, middle of the week. Just some updates. Quiz on homework 3, still due Sunday. But I've updated the late policy, so this pertains to homeworks and main class assignments as well. You can turn it in for 1 day late for 50% of your grade, and then I'm going to cut it off on campus. But if you have any extenuating circumstances, like you've gotten sick or anything else that is brought up, you can email me in enough time for a section. And then, quiz in 2 weeks from now, test in 2 weeks from now, and I think that's about it. So let me just go ahead and get started on notes. Does anybody have any question about the homework or any simple random sampling before we start? All right. So today we're going to continue on with some other types of sampling methods. So sometimes we can't take a simple random sample, or it's not best for us to really do that. And so I'm going to use a continuing example here. If you want to sample students in dormitories, there's a couple of different ways you can do it. I'll just do a little bit on the board here, just one floor. So I've got one floor here. Let me get some categories. And suppose this represents the rooms on any form of dormitory, first, second, third, that type of thing. And so one way of doing simple random sampling with students living in dorms is just taking all of these here and just picking out 30 of these if you're doing a random sample. Another type of technique is called stratified random sampling, where I'm have these these methodological groups of treats here. We got a chocolate covered strawberry, we have, looks like flan and sort of levels in that, maybe some chocolate on top. And so the way to do stratified sampling is in 2 steps. Let me just erase this up here. So with simple random sampling, if you remember last time we had 3 steps, figure out what you're targeting, set your numbers up, and then pull a random number generator to select the people from your population. The way we're going to do stratified sampling here, so stratified sampling. So step 1 is to divide the population groups here into something called strata. Have any of you heard of the word strata before? Not very many. Essentially it means just populations of units into groups. So grouping. That's the way I like to think about it. And so in a way that makes sense for your particular research study. Step 2 is going to talk about choose a simple random sample from each strata. And then gather your data. And so some benefits is that it'll produce a sample that's a good representation of the population, but sometimes is expensive to implement. So the example of talking about this types of college dormitories, the groups that we're making here are for undergrad and graduate dorms. So if you wanted to get an equal sample across the whole university, you might take 10 or so people from each major in order to get a good representation of your population. But you can see how that might be harder because if you're taking, let's just say there's 20 majors and you're taking 10 from each. I'm a lot easier to get 200 people to fill out my survey than I am to get 10 from each one because, you know, what if each major is a smaller amount of people and it's much harder to reach those people as well. And so in this, we're taking a simple random sample of 15 rooms from each of the strata for each 30. So suppose this is, I'll put undergrad here, and I'll put grad here. I'm actually going to just do 5 from each on the board. But suppose, you know, 1, 2, 3, 4. Each of the rooms. And so I do a simple random sample for the first part, and I get numbers 5, 17, 10, 3, and let's just say 14. So I'm going to circle these, and I'm actually going to use black to do so. So black, 17, 14, and 10. And I do the same type of simple random sample, but for graduates, and suppose I get 9, 4, 8, 10, and 6. And so now, instead of just getting these, I have a balance between undergrads and grads in my survey, compared to if I was just going to do a simple random sample, I would have a higher likelihood of selecting more people from my undergrad group than my grad group. Does that make sense? Another way of grouping is through cluster sampling. So I have a whole bunch of the states here, a map of the United States, just to represent how we can cluster sample. Does anybody need this on the board still? Okay. Let me erase that. So we're going to talk about cluster sampling. Can anybody tell me what a cluster is or where they might have heard the word cluster before? Yeah, it's another type of grouping. But when you think about clusters, kind of think about points that are really close together to one another. And so clusters, what we're going to do for cluster sampling, it's another type of grouping mechanism, similar like the strata. But I'm not separating it based on like male, female, or undergrad, graduate. I'm separating it into other clusters. So 1, divide populations into clusters. And so these clusters are pretty much like convenience for you. So suppose you lived in Pennsylvania, you could get clusters of each region. You could get southeast, northwest, southwest, northeast, midwest, and so on. And you could get a good sample from each of those general states. So step 2 of cluster sampling is just choose a simple random sample of the full clusters. That's what makes it different here. Full clusters from every subject. And And so this is where it's different than the strata. Strata, you're having two groups, similar like maybe the clusters here. But clusters, you're getting everyone in that cluster. So if I pick, let's just say major, let's just choose psychology. I'm going to choose everyone in psychology for that particular cluster, instead of strata where I only do 10 from them. And so I do a simple random sample from these other clusters. And so one of the downsides to cluster sampling is that you may not get something that's representative. And that makes sense, right? If I'm doing the entire United States, and suppose I select a cluster that's in the Southwest, I'm only really going to get people who've lived in, mostly hot weather for their whole life compared to the Northeast or the North Midwest, where they can live up to temperatures of, negative 20 or so on any particular day in winter. But it's actually easier and cheaper and faster than using stratified sampling. And that kind of makes sense too, because you only need to do one region instead of all of them. So if I'm going to do this with my undergrad and grad dorm clusters, so like I say here, divide a population of units into groups, and take a random sample of the clusters and measure only them in their particular clusters. And so now I'm taking a random sample of 5 floors only. So let's just see here. And I'm not even going to bother doing the vertical ones because I'm sampling each floor. So suppose this is undergrad, and this is grad. And so if I'm doing a random sample, here's where the simple random sampling is applied to. And so out of this, unlike the strata, I restarted with 1 at that next cluster, right? Because I was doing a simple random sample from here and 1 from here. But now I'm doing 1 all together, but I'm combining all of the rooms together in that. And so if I'm just doing 5, let's just say I pick 3, 5, 7, 2, and 8. Is the 5 that I pick. Three, 5, 7, 8, and 2. And so while this might be a big study, it's just really easy because I can go up and down the floors and ask the RAs, hey, can you hand this out to all the people on your first floor? And therefore, I'm only giving out paperwork to 5 people instead of 20 people individually. And I'm getting more people this way as well. But suppose I'm trying to understand something about the football team, and all the football team players live on the 4th floor. Do you think I'm going to get a representation of what the football team thinks with this sample? No. And why is that? That's right, because I'm not sampling that particular point. Now, if I were to do stratified sampling, I'd have a much better shot at capturing that. But cluster saves time. Does that make sense? All right. So to systematic sampling. Go ahead and remove this again. All right, systematic sampling. So for this particular sampling pattern, there's also 2 steps, but it's different. So before we talk about simple random sampling, where there's no groups involved at all, and you just randomly pick people. 2, then there's the stratified sampling, where we do have these groups, and I do a simple random sample in each group. Then we have cluster sampling, where I combine all of those people in those rooms into one unit and sample the units. With systematic sampling, I'm going to, and this is a little bit different than this, I'm going to arrange the sampling frame. And we'll talk about that in a bit. I arrange the sampling frame. So list of people in population. In some natural order. And this is pretty general in terms of the definition. But you can think about this, if I was going to line everybody up in this class and I was going to try and measure height, what some type of natural order might be is shortest all the way on this side and tallest all the way over here. And so in step 2 is going to be choose every kth unit. Unit from the sampling frame to gather data. So basically there's about 70 of you in this classroom, and what I would do is count off and say my k is 5. So I'll do 1, 2, 3, 4, 5, pick them, 6, 7, 8, 9, 10, choose them, go all the way down until I pick the 70th person. And that way, I would have 70 over 5 people, which is going to be 14 people. And so kth could be every 10th, every 25th, every 112th, and so on. But you want to make sure your value of k allows you to get through the sampling frame only once. So what I wouldn't do is go through 5 and then start at this end again. I wouldn't want to do that. And so one way you can imagine doing this with the undergrad dormitories and grad dormitories and I probably should not have erased this the first time, but that's fine. Okay. And suppose I was just going to choose every third or so from that. So I know it says 11th up there, and you can kind of count all the way through, but I think 3 is an easy number to count. So 1, 2, 3, 1, 2, 3. And the order is kind of going like this, where I go this row down and keep on going left to right. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, and 3. And so I've gotten to the end of my sampling frame, and now I'm done doing my sampling. So out of these here, I have 3, 4, 8. 8 people, 5 from undergrad, and 3 from grad. So it's a good alternative to random sampling, but it can lead to a biased sample. So if you choose k to be 12 from that, what you would be doing is just selecting the first row of people who live on the end every time. And of course that would be biased because, you know, sometimes on the end of dorms they have bigger rooms and so on. All right, so that is systematic random sampling. Now there's also non-random sampling techniques, things like convenience and volunteer sampling. I'll also write this on the board. So this might be, you know, convenience sampling, where if you've ever gone to Kroger or anything like that before, they might have said, oh, how pleased are you with this service, right? It's just convenience because it's just there on the keypad, and all I have to do is type in one number, and then I'm free to go. And that's also an example of an exit poll. And an exit poll is something like the senior survey that they ask, where before they leave, they ask the seniors what's going on. I could also give you guys an exit poll and say, you know, what did you learn in this class? Did you like it on a scale of 1 to 10? And then you can leave from that. And then another one is phone or online these days, really. Online surveying. So some people do these online surveys for money, and they get a non-random sample technique because it's people who want to get money that will do that. It's obviously biased, but it's a good way to get samples. All right. There's also a combination of different techniques called multi-stage sampling. And basically what I want you guys just to get out of this is that you can combine different sampling frameworks together. So like I have here, I want to stratify the population by region of the country. So doing something like cluster, but involving some stratification as well. Or for each region, stratify by urban, suburban, and rural, and take a random samples. Then divide into city blocks, sample some blocks, and then everyone on the same block or within the area may be sampled. So if you really want to get complicated about it, you can combine different sampling techniques at different stages as well. This one's really just built off of everything else. So all I want you to remember is that it's basically a combination of these. So errors in sampling. There's quite a few errors that can pop up whenever you're doing different sampling techniques. We've talked about them a little bit, like biases and things like that. But I'd like to write down a few that I think some general types of errors that can pop up. And so one type can be sampling error. And what sampling error is the difference between the sample values and populations because you're not measuring all subjects in the population. Or we like to call it expected error. And so this is, this is going to happen every time. You're not going to get perfect differences within your population. If you ask everyone, the census, right, is a good way to measure everyone in your population. But there's always going to be errors with sampling techniques, and that's where sampling error is going to arise. Another technique that you should not try to encounter is this type of non-sampling error. And so non-sampling error results when you've done something wrong. So can anybody think of what one example of a non-sampling error might be? Can anybody provide me an example with some non-sampling error?
Like for systematic sampling, if you just count wrong.
Yeah, right? If I just count from 5 and then halfway through to 40, I forget what my number is and I choose every 3. There's going to be a bias of more people in the later half that might be taller than people in the right half. All right. Any other examples? You can just think of real life examples too, like somebody who's passing out the survey and they forgot to copy both sides on the sheet. That's also an example of just non-sampling, because they can't even answer those other questions because, I've had cases where I have a test. I'm like, oh, I'm done, and then I look, there's a backside. I'm like, oh, I have 5 minutes left, So it's just something that you've done wrong. Some examples of this is that you sample too small. You don't get enough people. Notice you didn't randomize. Or your error in data collection analysis. So like I was talking about before, with actually people getting these surveys. Okay. Awesome. Well, now we can get into some difficulties and disasters in sampling. And I say disaster here lightly, it's, it's not like, I'm in Chernobyl or anything. It's not that level of disaster with sampling, but it can, affect your research and picked it that way. And so some examples here are you might use the wrong sampling frame. You're not reaching the individuals you want to, like I was talking about with that 4th floor over there. If you don't reach your football population at all, you failed if you want to understand them. Non-response or non-participation, a self-selected sample or convenience or haphazard sample as well. And so I'll talk about the sampling frame for a little bit. The sampling frame is listed units from which you get your sample. So when I'm talking about the 70 people from up here, every case is talking about that sampling frame. And so one example is using a telephone directory to survey the general population, but it excludes those that move. So those with unlisted home numbers or people that don't even have home phone numbers anymore. And so this comes from the book right about 2015 when people actually do have home phone numbers. And nowadays, most people just have a cell phone number. So if you're trying to call people and give them a survey, obviously you're already going to be biased because you're only going to give people who own a phone. And so if you want to get all adults, then there's people that has no landline or unlisted phone, and you can't even sample them. You can only sample the people that are in the phone directory or whatever. And so I do have personal experience through this. I've actually had to call people and give them a senior survey at my previous college. And basically, you only have a list of the people's phone numbers from, when they applied to the university. So say you changed your phone number in that time. Well, I'm not going to be able to contact you. So you're obviously someone that's unlisted from this. And so one reason they say is use random digit dialing, which is, I'm just going to punch in numbers and hopefully I get someone, right? If you have a more complicated technique than that, you may have to resort to maybe some type of stratified sampling or cluster sampling as well. You can also not reach the individuals. And so some examples of this are telephone surveys tend to reach more women. Some people are rarely home. Others screen calls or they may refuse to answer. I get like 5 to 10 calls from random phone numbers all day. And lo and behold, what if somebody just randomly calls? I'm like, oh, okay. I'll answer for about a second and I hear the whoop sound and then I hang up. Because I know that's a telemarketer or somebody else calling me that I don't need to talk to. And so you may encounter people if you're trying to do a phone call survey that resort in that. If you think about doing online surveys, if you send out an online survey to somebody, you may be restricting the older population because they might not have access to internet or even a computer. Heck, I know plenty of, my grandfather and grandmother don't even have cell phones nor internet. So the only reason you're going to be able to reach surveys out to them is either to mail it to them or give it to them in person. And then there's these types of things called quickie polls to just get a whole bunch of people to answer in one night, maybe through a Google form or something like that. And so I've talked about surveys a lot, and it's mostly where a lot of these sampling techniques are coming from, right? You want to get information from people or from people who are highly knowledgeable. You're going to send them a survey. And so there's different types of surveys out there. And one of them that I'd like to mention is called a Likert survey, or Likert. How many of you have heard of something called a Likert survey before? Or Likert questions? Yeah. A few people out there. Can anybody tell me what they are? What's an example of a Likert question, or Likert? Well, one example is just having, do you believe 8 hours is too much sleep. And this is an opinion question. So I'm going to have answers that go from strongly disagree to disagree to neutral to agree, and then strongly agree. And then some samples they may have like not applicable or refuse not to answer or whatever, because you always want to include those questions on surveys to let people skip on by if they prefer to. You don't want to force anybody into answering a question they don't want to. And so off of this, let's just say, I disagree, I like getting sleep. And so the liquor is basically going from strongly disagree to strongly agree, creating some type of ordinal variable scale. Where disagree is more opinionated than strongly disagree, neutral is more than disagree, and so on. And so analysis, you can make this a 1, a 2, a 3, a 4, a 5. And people actually create means across certain questions in order to represent, they're generally positive if it's above 3. If it's below 3, they're generally disagreeing with your questions. Okay. Does anybody have any questions about Likert scales or what types? Alrighty. So other potential pitfalls of surveys. So some surveys, like I was talking about before, you may have a non-response bias where people, I have questions 1, 2, 3, all the way through. Suppose you're filling out, there's like the exit survey for classes, the spot surveys, right? And I may have a large text box here, and I don't really want to write something about my professor, so I'm just going to write NA in here and keep on going. And that's an example of having non-participation bias, is because they're not answering all the questions in your survey. A type of response bias is that you're trying to get a random method to choose a sound representative sample, but some subjects provide inaccurate information. So one reason of this is, suppose you're filling out this survey and you want to be funny, and they ask, what's your age? And then they just have a text box here. And then I type in 500. I'm like, no one's actually 500 years old. Not a human doing this, maybe some turtle or something that we talk about this survey. But for that particular question, that's the type of response bias because you can't even use that answer. You don't even know what the true age of the person is because they decided to be funny and put a random age in there. Another reason is if you're asking for sensitive information, some person might lie. So there's a lot of studies about, consuming marijuana and that type of thing. They're saying like, oh, do you do this? And if you're applying for a government job, you can't say, well, I've done this before because, they kick you out. And so I may or may not be accurate on that. That's just the information I remember. But somebody might put some misleading information that they might have done it, but they'll just say they haven't done it before. And you have no really cause to understand how they did that. And sometimes subjects don't even know they're providing inaccurate information. So they may be in a hurry to do this survey, and I suppose I only have 10 minutes before class, and I'm typing all these answers in, and I just look loosely over the question. I'm like, yada, 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 I understand this. So one way this has happened before is if you have a whole bunch of Likert type questions, and you have them in a row, and then suppose you have this other set down here that reverses the scale. So it'll go from strongly agree to disagree over here. And so you're going to think, go all the way down, all right, I click this one, this one, this one, this one, I strongly agree. And you go all the way down, you don't even read this question, and you've actually disagreed to somebody that you actually strongly agree with. And so, this is why when you're planning out these surveys, you either have to have like some type of page break when creating these surveys, or some type of washout period before you reverse or scale, or you show them in bold or italics or underline just to get people to read it. And so you can also have leading or vague survey questions. So leading, like I lead you to say one particular answer or not. Ones that say like, how often do you like to go out to tots? And if it's something about social participation, some people might feel more willing to say that they go out more than they actually do. And then two other ones are volunteer or self-selected. So if they feel strongly about the topic of interest, they're likely to respond about the survey questions than those who are uninterested. So suppose I'm asking you a question about psychological impact of ibuprofen on the system. And if there's people who are interested in neuro psychology, they're going to be more interested to fill out that question than, say, someone in another major who's just trying to get this done. So a lot of people, when they're just filling out surveys, are just going to try and answer as quick as they can, go all the way down, just so they can either get to that incentive at the end or just say that they did it and they helped someone out. And so when you are designing these surveys, you want to design them so everyone's reading these questions. And the last one is lurking variables or confounding factors. But one way to control for these is to ask direct questions that answer what you want to understand, what your research question is. And so here's some just biases that can happen in surveys. So we have selection bias, like what we talked about with choosing not that fourth floor. Non-response bias is when it's chosen, but either people can't respond or you can't reach out to them out of the survey. Or a biased response is when they respond differently than how they feel. An example of that is the consumption of marijuana. Does anybody have any questions about any problems with surveys or biases so far? Maybe something they've seen before and want to understand something about it? All right. So now we have the non-response, volunteer response, and non-participation. So I've talked about these a little bit. Here's just a slide of information on it. But essentially, volunteer responses are not likely to represent your entire sample. So if you're only having people that you reach out to and then you just send it to all your friends, all those people are going to be volunteering to select for your survey instead of methodologically picking 20 friends and telling them, please do my survey, do it, or you might say or else, or just get them to fill it out. And so when you repeat, when you conduct these studies, you may see a response rate at the top. You may see 15% response, 20%, 25%, and usually anything above 25% or so is really good for a survey. And depending on the type that you have, the longer you do a survey, the less people are going to fill it out completely. And so how do we ask different survey questions? And we want to avoid these types of response bias by framing our questions carefully. So one is deliberate bias. The wording of a question deliberately biases the response towards an answer. So one example of this is you may have misleading words in there. So how often do you shower before bed? Or do you, hold on, I reframed it wrong. Hold on. Do you often shower before bed? And then you say yes or no to this. So can anybody think why this might be an example of some type of deliberate bias? Yes?
It's like people probably have different definitions of the word often.
That's right. So often might mean 5 nights in a week. Often might mean 4 nights, 3 nights in any particular week. And so based on people's own personal definitions of this, they're going to be more leaded to say possibly yes, because, oh, well, people think 2 times is enough to shower in a week. Other people think they need to shower every day. So based on personal definitions, you're going to be leaded to choose yes in this more than no. Another concept is unintentional bias. So questions worded so the meaning is misinterpreted by a large percentage of the respondents. And so one example of this is, do you often eat snacks? And so some unintentional, well, what's a snack, really? If I have a Lunchable, is that a snack? Some people might call that lunch. Some people might just call it a snack in the afternoon. Depending on the wording that you choose, you need to have concrete definitions of what they mean. So words like often usually should not be used. Words that are too general, like snacks or just often before bed. These type of things. Well, how long before bed does that count? Technically, if I shower in the morning, that is before bed at night. So it's just a much longer time before bed. So you need to be really concrete in your questions. Another example is desiring to please. You want to have a desire to help the question, help the person who is creating the survey. And so it tends to understate a response to an undesirable social habit or opinion. And I kind of used this before, but one question, do you like to go out on the weekends? Or do you go out on the weekends? If you're saying yes to that and trying to help yourself or help them out, then you're trying to please that particular person and inducing bias that way as well. Another source of bias in surveys is asking the uninformed. So they don't like to admit that you don't know what you're talking about when you answer them a question. And so one might be, do you remember about the type of deer that we talked about in last class? And so I'm sure a good majority will be like, oh yes, I remember the notes completely, and I remember that it's a, pair, I don't even remember it now, it's a pair David deer or whatever. And so based off of that, more people are going to be like, yes, I do know what you're talking about without asking further questions about it. Unnecessary complexity. If questions are to be understood, they have to be kept simple. So some questions ask more than one question at once. And so if I'm using some complicated terminology in this, as some people might know, I have down, do you believe that doing statistics requires the use of an inherently programmed calculator or possibly a multi-threaded high-performing computer? So raise of hands of who understood what question I was asking. Yeah, absolutely not, because I'm using all these complicated verbiage to explain this question that doesn't make any sense. Ordering questions, I think this is pretty self-explanatory. Some questions and surveys have things called bridging logic, where if I say yes to this question, then I ask how many nights, right? And so I can't reverse the order. I can't say, well, how many nights do you shower before bed? And then ask them, do you often shower before bed? That doesn't make any sense. You have to have an ordering to your questions. Another example is the last type of concept we'll talk about with response bias is confidentiality and anonymity. And so confidentiality means you're not going to release information, but you know who that person is. So if you're on Qualtrics or SurveyMonkey or another type of surveying platform, you get an IP address of the person who answers them. If you send out an email list, you know who is answering that particular survey. If you keep it confidential, you can have that IP address with them so you know that they're identifiable. If you say that your survey is anonymous, then you remove all those IP and personally identifiable information to them. so whenever you're releasing a specific type of survey, you have to be concrete on what you're talking about. I know I keep on saying that. But that's why we have things like the Institutional Review Board, which helps go over a lot of surveys that people release to the public. So generally, be sure you understand what's measured. Words have different meanings. It's important to get a precise measure of what's asked or what's measured. So who is really unemployed? Are they underemployed, which is an economic term that says they're in a job right now, but it's not as good as what they could be doing or what they're undergrad for. So one example of that is somebody who has a master's, and then because of the economy or something, they have to end up working at Walmart. You know, Walmart's not really suiting, you know, as a cashier or something, it's not really suiting their personal qualifications. Another way is that some concepts are hard to precisely define. So how do you measure intelligence? Well, IQ is one way, but the IQ test has been shown that it's not really that effective, and all it does is measure your ability to learn instead of how much you already know. And then how do you measure attitudes and emotions? How do you measure self-esteem and happiness? And so I'm not really well-versed in understanding how do we personally measure self-esteem and happiness, but I'm sure there are different measures in other fields that tell, you know, how happy one person is or how confident they are about themselves. So open or closed questions, the choices be given. One open question is you're allowed to answer. And so just for a quick differentiation between open and closed, open is like, tell me about your day. And then you're given a big old text box, and you're allowed to write in whatever you want. And for analysis, it's kind of hard to summarize because then you have to take what people told about their day and then put them into other categories later. Like they say, went outside, played with pets, took class, and so on. So you have to make categories after you're already done answering that question. Compared to a closed question, which is just something like this, where they have to fill in one of these bubbles. They can't type in whatever they want. And so basically, if you prefer closed questions, you usually first have a pilot survey, which is just saying, giving it out to people first so they understand what they're talking about. And then based on those categories that you create from the pilot survey, then you can make a closed version question of that. And so I'm just going to end with talking about this case study 5.2 that talks about the 1975 Public Affairs Act, which doesn't exist. And in 1978, they're like, oh, well, do you like this or do you not want it to become law? And about 1/3 had an actual opinion about this, about a law that doesn't exist. 1,000 people that say it should be repealed, 43, and I'm going to write this on the board. I know we're almost running out of time, but I've got this in one other slide, so hold with me for a second. So we got 43 have an opinion, and then 24% think it should be repealed or put in action. And then another poll later asked about 2 separate groups of 500 randomly selected adults. And then they kind of found politics with this. And when politics is involved, people tend to be more motivated to answer. And so while a Democrat thinks it should be repealed, of course more Democrats are going to align with their political beliefs about an act that doesn't exist. And similarly on the other side, more Republicans said it should be repealed instead of the Democrats. And so essentially here, don't mislead people on your surveys. You want to be understanding what exactly you want to measure and present that in survey questions so that it makes sense. All right, thanks guys.
Thank you.